and catch the beginning of this presentation. Welcome everybody to the University of Minnesota Climate Adaptations Partnership webinar today. Today we'll be talking about the Minnesota Climate Mapping and Analysis Tool, also known as Minnesota CliMAT. And this is a tool to see highly localized climate projections across the entire state of Minnesota. My name is Katie Black. I am an extension educator with the University of Minnesota, housed within the Climate Adaptation Partnership. I focus on climate resilience within agriculture and food systems. With me today is my colleague, Dina Kaufman, who is our GIS specialist for the Climate Adaptation Partnership. And she'll be talking to you about how you can use the tool. Dina, you can go ahead to the next slide. I just want to start with a brief bit of housekeeping today. I know we're probably all pretty used to Zoom, but for those of us who are not, there is a toolbar that you should see at the bottom of your screen. You can click on an icon to open the chat function and communicate directly with us as webinar organizers. If you're having technical issues or have a question you don't feel comfortable raising in the Q&A, the Q&A feature is a great place to ask questions. You can submit questions, you type it in, and it will be logged for us to look at the end of the presentation. In the Q&A feature, you can also upvote other attendees' questions. So if someone else has asked a question that you really want an answer to, you can give it a thumbs up, and we'll know that that question is important for a lot of people in this session. If you'd rather ask a question directly, you can raise your hand via the hand icon that you see at the bottom of your screen. We do ask that you wait to raise your hand until the end of the presentation, at which point we will be able to take questions. And as I said before, this webinar will be recorded and it will be posted on MCAP's YouTube channel at a later date for those who would like to go back and review things or share it with colleagues. Next slide, please, Dina. So to give you an overview of what we will cover today, we're going to talk about what the Minnesota Climate Adaptation Partnership is, and talk about some general climate change trends that we have already observed and expect to see in Minnesota. We'll give you an overview of the basics of climate data and climate models so that you are able to understand how this tool works and how to use it appropriately. We will give you an overview of how you use Minnesota CliMAT and how you might use it once you leave this webinar. We'll end with talking about some learning opportunities from MCAP to dive more deeply into this tool and other climate adaptation work. And to wrap up, well, like I said, we'll have time at the end for Q&A. Next slide. So we've told you a little bit about what to expect from our webinar today, and we've introduced ourselves. But one thing that we would love to know is who you are. So I'm going to start a poll here that you should have access to. It should pop up on your screen. Please feel free to share in the poll what your affiliation or interest area is. If you're familiar with climate adaptation or climate data, and where you're zooming in from today. And we'll take a couple minutes to let folks respond. All right, so results are steadily pouring in. We have people from various levels of government, with most folks attending from state government. We have some folks from higher education, some nonprofits, some private industry. Looks like most people here today understand what climate adaptation is, and are practitioners of it. And most folks have a relatively good understanding of climate data as well. So you are in the right place today, based on what you told us in the poll. Dina, you can head to the next slide. So I figured that now, if you're not familiar, you might want to know a little bit more about us and the University of Minnesota Climate Adaptation Partnership. Next slide. The University of Minnesota Climate Adaptation Partnership, or MCAP, as we'll refer to it for the rest of this presentation, is an organization based at the university that is co-located within the university's research branch and extension. For those of you who aren't familiar, University of Minnesota Extension has programs like Master Gardener, Master Naturalist, there where community members can go to get direct answers to their questions or technical support. And then obviously the University of Minnesota produces a very large amount of world-class research. Within MCAP, we have both scientists and extension educators on staff. So that means that not only do we as an organization conduct cutting-edge climate research, but we also develop educational programs to bring that research out into the public. Next slide. MCAP's mission statement focuses on 3 pillars: collaboration, capacity building, and advancing climate-informed decision-making. I'll speak a little bit more about what those mean. So when we say collaboration, we know that coordination and collaboration are necessary to respond to a changing climate. 2 of our landmark programs are our annual awards, which recognize climate adaptation efforts across the state, and our biannual Climate Resilience Conference, which convenes climate adaptation practitioners from across the Midwest to share information, research, and best practices. In terms of capacity building, we help people build both knowledge and skills. So that means we produce climate resources, such as summaries and fact sheets and reports. We also host workshops where we train people to use climate adaptation techniques. We understand that understanding climate change does not necessarily lead to acting on it. So we also build capacity in the form of financial support, knowledge, and human resources. And finally, in terms of climate-informed decision-making, we conduct research to produce the most up-to-date climate information to incorporate in our programming. We want our partners to have access to the best information they can because we have to make difficult decisions under deep uncertainty. Next slide, please. This is a slide showing you MCAP's team. We are very fortunate to be in a period of growth here at MCAP, and we have a wide range of expertise. In addition to our directors who are in charge of advancing MCAP's mission and operations, we also have a climate scientist, a GIS specialist, a communications specialist, and a whole host of extension educators focused on a wide variety of sectors. We also have some really wonderful graduate students on the team who I'm not able to show you today. Please reach out if you are in need of assistance or are curious about a particular topic. We would love for you to think of these people as a resource for questions you have about climate adaptation. Next slide, please. And I'll just spend a little more time discussing our work. We have a wide variety of projects and activities going on at any one time. In terms of research, for climate research, we run climate simulations and collect ice in Antarctica to extend our historic climate knowledge even further back in time. We do analysis and communications research. We're looking at how people working in climate adaptation collaborate with each other and how you communicate to various different audiences about the risks involved with climate change. We have a number of applied projects in the works, such as creating resilience metrics for the state of Minnesota that would allow various agencies to assess how the state is becoming more resilient or not. Again, we have a large extension team on a wide variety of sectors. So they do workshops, webinars, and hands-on skills for adaptation. And then a lot of us do public engagement and training, like we're giving today, where we do talks about impacts of climate change, what we've seen already, and resources that we have available to deal with those climate change risks. Next slide. So now that you know a little bit more about us, let's move on to what we've seen in terms of climate changes to Minnesota already. This slide shows the observed temperature change using data from the Minnesota DNR, data from 1895 until about now across Minnesota. It's showing you the average annual temperature on the left, winter lows in the middle, and summer highs on the right. It also divides the state into north, central, and south regions. These data show that Minnesota's climate is already warming. In fact, the average annual temperature across the state has increased by 2.9 degrees Fahrenheit since 1895. However, you'll note that this increase hasn't been consistent by location in the state or time of year. If you look to the middle of the slide, you'll note that the most significant warming has occurred in winter. And if you look to the top of the slide, you'll note that the most significant warming has occurred in the northern parts of the state. So we may be losing aspects of our famously cold winters that Minnesota is known for. Next slide. Minnesota is not only getting warmer, but also wetter. Again, this is data from the Minnesota DNR. The 10 wettest and warmest years on record have all occurred after 1997. 2016 in particular was the wettest and warmest year on record. A kind of brain twister is that no warm year was quite as wet and no wet year was quite as warm. We've also observed a 13% increase in the heaviest rainfall of the year. What does that mean? That means that the strongest storm of the year now results in 13% more rain than it used to. And we've also observed that the growing season, also known as the time between the last frost and the last freeze, has lengthened. It's lengthened by about 2 weeks across the Midwest since the 1950s. Next slide. And in addition, across the Midwest, we've seen that the climate is becoming more erratic with transitions from wet to dry extremes happening more quickly and more frequently. I don't think I need to talk about this too much. I think most people attending this webinar who are based in Minnesota can think about any number of years over the past few years where we've seen these transitions from really wet to really dry occurring in various parts of the state. Next slide. In the future, Minnesota's climate is projected to continue to become warmer, wetter, and more extreme. So now we're thinking about what we can expect for the future. So when I say warmer, I'm not talking just about warmer on average. There will still be variation around that. So far, we've mostly seen warmer in winter, but in the future, we also expect to see warming in the summer, including an increased number of extreme heat days. When I say wetter, again, wetter is on average, but some seasons, like summer, will actually become drier than what we are historically used to. And we are also expecting to see longer dry spells between rains and more intense rainfall when it does rain. And when I say more extreme, we expect, again, to see more rapid transitions between very wet and very dry periods, and that we may see stronger storms as well. And so even if we ceased carbon emissions today, we would still experience the impacts of climate change because carbon hangs out in our atmosphere for a very long time. So that means that we must reduce climate risks through adaptation. We will be living with the impacts of climate change. We know that adaptation can bring multiple benefits, such as benefits to how we build our housing, how we take care of people in a healthcare setting, how we manage our tribal and agricultural and wild lands, and how we build our infrastructure for people to get to where they need to be in emergency and non-emergency situations. One thing to note is that this next decade is a really critical time for setting us up well to be able to respond to these changes when they happen in the next 15 to 20 years. And for those of you who aren't familiar what I'm talking about when I talk about adaptation, it might seem like jargon and they don't necessarily mean the same thing within the climate community that they do if you hear them with people using them in informal conversation. So when we're talking about climate change action, mitigation refers to preventing climate change at the source, reducing emissions, and using carbon capture. When you hear people talking about achieving net zero emissions, that is a form of mitigation. Again, adaptation is about preparing for climate change effects because we are going to have to live with some of those impacts in the future, regardless of how we act today. Adaptation strategies are things such as building back further from coastlines because of the risk of flooding or creating buffer zones to prevent wildfires from spreading. The thing that we are always want to point out is that national dialogue focuses on mitigation, but because climate change is already happening, we need to focus on adaptation also. Both are needed and both have co-benefits. And if we go to the next slide, excuse me. We can see that climate adaptation activities are already happening in a number of states. So this is a map of the US showing the number of reported state level adaptation activities happening between 2018 and 2022. Here in Minnesota, we have the Climate Action Framework, which is a plan to prevent and prepare for climate change. And the take-home message I'd like for you to get with this slide is that to adapt and to advance the number of activities that we see on this map, we need to better understand the risks that we face, and we know that risks are locally specific. So if we look at this next slide, this map is showing us the projected change to average annual losses by flooding in 2050 as a result of climate change. Projections that you see are averaged for each county. again, this is a lot of data to take a look at, but what I like about this map is that it illustrates really well how climate risks are location specific. So as you can see where it's a darker green color, the risk of flooding along the Gulf Coast is much greater than in the middle of the country. And that means it would be unwise to apply Florida's flood risk estimates to preparing for floods in Minnesota. And even within Minnesota, flood risk varies depending on the county that you're in, with counties in the southwest portion of the state having lower risk than counties along major rivers. So it's important to have local information when planning for climate change. And information at a more local level, such as at regional or city scales, is more relevant and useful for adaptation planning. Next slide. So that brings us to why we're here today, to tell you more about this tool, MN CliMAT, that will give you local information to make locally relevant decisions. Next slide. But before we can tell you about Minnesota CliMAT, there is a bit of important background information that I need to share. We won't get too technical, but it will help your understanding of how this tool works and how to use it. Next slide. There are two fundamental types of climate data. What are they? Historic, which is calculated from observations, and climate projections, which are simulations of what climate may look like in the future utilizing computer models. Models allow us to simulate the Earth's climate in order to understand how various systems behave and interact, particularly when altered by greenhouse gas emissions and different levels of those. The thing that both of them have in common is that both include characteristics like precipitation, temperature, and humidity. Where they differ is time scale. Where they differ from weather is time scale. So when we're talking about weather, you can think of it as the clothes you wear on a given day. Climate is the clothes that you have in your wardrobe for living year-round in Minnesota. So again, we're talking about a time scale of about 20 to 30 years when we're talking climate data. Next slide. Oh, perfect. And again, Minnesota CliMAT shows climate projections, which have been simulated by models. We don't have time to do a really deep dive today, but I do want to tell you a little bit about what you need to know in order to understand climate models. So global climate models used established mathematical and physical equations to represent the Earth. They're simulating the laws of physics, chemistry, and the biology of the Earth to represent our atmosphere, land cover, and water and ice around the globe. Basically, what a computer is doing is taking all these components into consideration and looking at how they behave based on different levels of carbon in our atmosphere. And when the computer is able to solve that equation, it spits out a 3D picture of what we can expect for the future. Again, because we're not really going into the nitty-gritty of climate models today, I would just like to let you know that we have plenty of information, including information on MCAP about global climate models. We have a great climate primer that I would encourage you to read if you're more interested, and that the science of climate models is well understood. Climate models do not exist in just one part of the country. It is an international effort, and there's not just one climate model. There are actually dozens. So we need to make sure that their calculations can be compared to each other in an apples to apples way. We don't know exactly what the future will hold, so we envision a few different possibilities and call them scenarios. Each model is run with these scenarios to simulate a range of potential outcomes for our future. I won't go again in too much detail for these, but we have 5 different shared socioeconomic pathways, which are our scenarios. Our first scenario, SSP1, is all about sustainability, which is a scenario in which the world would shift towards sustainable development, high levels of global cooperation, greater equality, and low material consumption. Our second scenario, SSP2, is often referred to as the middle of the road scenario, where economic, social, and technological trends follow historical patterns and inequalities persist. You'll also see this scenario referred to as intermediate emission scenario. Our next scenario is SSP3, also known as a regional rivalry, which is that countries do not work well together. There is a lot of focus on the expense of security over international collaboration. If we look at SSP4, that is also known as a divided road, where we see unequal investments across the globe in knowledge and capital investment in response to climate change, and we see a less educated labor-based society. And then our last scenario, SSP5, relies heavily on fossil fuel development, where we see continued competitive markets relying on the use of fossil fuels. For today, what I would really like you to focus on is SSP2, SSP3, and SSP5, because those are the options that are available for you to look at in your tool. Again, these can be thought of as intermediate high for SSP3, and for SSP5, very high emissions, and scientists agree that it looks like SSP3 is what we are most likely on track for. This is a slide just showing you how SSP correlates to amount of CO2 in our atmosphere and what that actually means for global mean temperature. So we have carbon emissions on the left and global mean temperature on the right, and those are color-coded by SSP. So you'll see that SSP5, for example, has the bright red line at the very top showing high amounts of carbon, and also the highest increase in temperature change by the end of the century. And if you look at the opposite end of the graph and we look at SSP1, again, we see CO2 levels actually decreasing by about the early 2100s, and we see less warming because of that. The SSP2, 3, and 4 are somewhere in the middle between those two extremes in terms of amount of carbon in our atmosphere and what that correlates to in terms of warming. And again, one thing that we are always careful to point out is that the warming that you see by the end of the century or early next century is on top of the warming that we have already seen today. And you can go to the next slide, Dina. Thank you. Global climate models are very powerful tools, but we need information at a more local level, such as at a regional or city scale, to make it useful for adaptation planning within our smaller cities and communities. Small, when I say smaller, I mean smaller than the entire state level. Scientists use downscaling to increase the detail captured by climate models, and this is how we developed the data for Minnesota CliMAT. So The way I would like you to think about this is that the detail across time and space that a climate model can represent is determined by its resolution. So when we downscale a climate model, it means that you would be able to zoom in more clearly. Think about if you're looking at a picture that has higher resolution, you really zoom in, you're able to see a lot more clear detail rather than kind of pixelated information. And again, that's a lot more useful if you're trying to look for something specifically within that picture. One thing to note with this slide also is that our climate tool has dynamically downscaled data. There is statistical and dynamics downscaling, which we aren't able to get into today, but ours uses dynamically downscaled data. So with that, I think I'm going to let Dina talk about Minnesota CliMAT and how you're best able to use it in the work, and hopefully get you to where you need to be so that when you leave this webinar, you know how you'll use it, or at least know where to go to get more information and training about it.
Awesome. Thank you, Katie. So yeah, as Katie mentioned, we've been talking a lot about climate models, about this big tool that we've got that recently launched. And so we're going to get into the sort of nitty-gritty and walk you through how to use it in your work. So this is what the MN CliMAT, the Minnesota Climate Mapping and Analysis tool, looks like. So if you go to that link that's at the top of the slide, the app.climate.umn.edu, you'll see something like this when you land on that page. And so this tool provides high resolution statewide projections up to 2.5 miles wide. So for reference, 2.5 miles, that's about the size of the state fairgrounds. So that does enable us to really look specifically at different cities, towns, counties, and get really detailed climate information from there. So the tool provides data for multiple future time periods, mid, late, and end of century. You can use it to compare different emissions scenarios using those SSPs that Katie discussed before, and a ton of variables, which I will get into and walk you through. So this map that you're looking at right now is the difference from historical simulations and future projections for days that exceed 90 degrees Fahrenheit under an intermediate emissions scenario at the end of the century timeframe. So our tool provides 3 future time periods, and that's going to allow you to explore what's most relevant to your field or your concerns. So those historical simulations is what these models are based on. And then you can look at the mid-century, so 2040 to 2059, late century, 2060 to 2079, or end of century, 2080 to 2099. And it's important to remember that when we talk about those time periods, what we're referring to is when you see a number that says, you know, temperature will increase by this much over 2040 to 2060 by the mid-century. It refers to an average that's been averaged over that whole 20-year time period. So that can cause some confusion if people think that that might be the total for every year or something like that. Remember that that's the average over that 20-year time period. So we've chosen to look at 3 different emissions scenarios to show in the tool a range of possible futures that include sort of a very high emissions scenario at the end there, that 585, down to a more intermediate emissions scenario to really help people make decisions based on a wide range of possible futures. So as a reminder, that SSP stands for Shared Socioeconomic Pathways. And those 3 different scenarios represent the potential pathways forward that we can take, which all differently affect our climate. And those numbers, those 245, 370, and 585 that you see in those different emission scenarios, those are refer to the complementary representation concentration pathways, or the RCPs, which some of you might be familiar with if you've done some other climate work. So the MN CliMAT tool has many different variables, and I'll walk you through some of the variables, and I suspect that many of you are going to look at these and sort of know what you might need, but I hope this also helps you sort of maybe point to a few variables you didn't know you needed. We've got 30 plus variables that kind of fall into these broad groups: precipitation, temperature, soil, and lake variables, as well as humidity. And I'll sort of talk about more detail about what each of those variables, the different breakdowns that we have for those, and what you use them for. For the precipitation variables, you can look at projections for the values of rainfall or precipitation in inches, thresholds, such as the number of days with a certain amount of rain. So maybe you want to see the number of days with precipitation greater than 0.01 inches. So did it rain at all? Or maybe you might be interested in a higher rainfall. So you might use the 2 inches projection. We can also look at dry spells during the growing season, and as well as maximum 1 day to 7 day total precipitation. So if you're interested in the amount of rainfall that falls just in a 1 day period, that might be interesting if you're looking at something like flooding. The tool also shows projections for snow variables like cover depth and the number of days with a snow cover depth greater than 1 and 6 inches. So what might you want to use these for? As I'm sure you can imagine, they're useful for flooding, dry spells and drought, looking at impacts on infrastructure, agriculture impacts, snow, as many of us experienced this winter. Maybe you're interested in projecting future climate impacts on winter snowfall. Are you going to have enough snow for skiing and other outdoor recreation activities in the future? And snow also affects things like wildlife that depend on snow cover, our infrastructure, our plumbing, and our pipes. MN CliMAT also shows us projections for a number of different temperature variables. So you can look at things like daily maximum, daily average, daily minimum, the number of days with temperatures above or below a certain temperature threshold, such as below freezing or sub-zero temperatures. And you can also explore the number of days at 90, 95, and 100 degrees. So those really hot heat threshold days, as well as relative humidity. So what might you use these for? Well, one thing that comes to mind immediately is for public health. 90 degrees is a really important temperature because once the heat index exceeds 90 degrees, it's more common to see things like heat-related illnesses. So that's something that you might be interested in, working with that projected data to see how things like that might increase in the future. How much precipitation falls? Looking at specific variables within precipitation, like how much precipitation falls at one time, how much over an extended period of time. Those differences and those nuances are really important for looking at variables for impacts on construction, roadways, things like heat and electricity, like air conditioning, for example. And also from the natural sciences side, more things like wildlife, water and water safety, or harmful algal blooms. We can also use these variables to look at humidity impacts. And so humidity impacts on crops and plants is really important, especially considering things like disease thresholds. And humidity also ties back into public health, which is something I talked about at the beginning of the slide. It affects how you experience heat. I think we can all relate to the fact that a dry heat feels much different than a humid heat. The MN CliMAT tool also offers projections for future soil and lake variables. So soil temperature, soil moisture, both of those are available at 4 different depths. And then lake variables as well, including frozen surface and temperature at the bottom of the lake. So what might you use these for? You could use these variables to look at impacts on future construction, agriculture. Soil moisture and temperature is really important for crops, forestry, and natural systems. The lake variables especially might be useful if you're interested in outcomes related to aquatic organisms and fisheries, outdoor recreation like ice fishing, and things like public safety, like falling through the ice, which is much more likely when the lake surface is less thick. You can also look at those variables over multiple times of year. So you can look at specific months even. So all of those variables I've mentioned, you can investigate those variables down to the specific month and have those projected for the future. You can look at specific seasons. For example, the growing season, which is May through September in our tool, which might help you sort of zero in on some of those impacts. Because as Katie was talking about, those weather patterns will shift through the season as the climate continues to change. So we're going to see rainier springs and drier summers, for example. And so that's something that data averaged over the year might not capture, but because we have that seasonal data available, you can really bring those impacts into perspective. So how do you use the CliMAT tool? Now that we've kind of covered the sort of data that you can get from the tool, how do you actually go about using it? On the landing page for the tool, you're going to see something like this, and you're going to want to click on that Create Map tab in the top center. And that's going to bring up all these different little drop-down menus. And you can zoom in and out to the map just to look at different scales. This is the map that is the sort of basic default when you arrive on that landing page that shows the full state of Minnesota, but you can zoom into areas that are interesting to you, which I'll talk about more. So that first drop-down menu is the area of interest. So if you define an area of interest, you can select one of those options or create your own. So in this picture, it's the area of interest is the entire state, but you can choose tribal boundaries, counties, even state parks, or many other options. So next, you're going to want to choose the emissions scenario and the time period you want. This option shows the end of the century timeframe under a moderate emissions scenario. And then you'll choose your variable. So what information do you want to look at? So this one is showing the difference between historical simulations and future projections for the number of days which exceed 90 degrees Fahrenheit. So you'll notice that as you change the options on those drop-down menus, the pop-up text and the legend will also update to describe the data. So the underlined portions here, by end of century and intermediate emissions, number of days that exceed 90 degrees Fahrenheit, though that underlined text, that's the variables that's going to change in that pop-up text as you toggle those different drop-down menu options. And so those variables will change to update with what you've chosen. So let's say we want to look at some data more locally, like a county level projection. So you can change the area of interest on that first drop-down menu and select a specific county. And the text at the bottom will update to show, to reflect that county that we've selected. So here you can see that changing the area of interest has changed that pop-up description, but it's also changed, it's added a label there, but you can still show it within the broader context of the rest of the state to compare. So you might want to compare, as I said, among different counties at that geographic level, but maybe you want to compare at a time, under different time horizons. So you can do the same thing to change the different time horizons. So these three maps show the same variable, days over 90 degrees, over 3 different time horizons, mid, late, and end of century. Or maybe you want to compare different emissions scenarios to show sort of the range of possibilities that we might see in the future. So these projections are also likely to shift kind of depending on what emissions scenario you use. So you can mix and match all of these variables depending on what kind of question you're trying to address. So as you're playing around with the tool and you're investigating, maybe you've sort of put together a map of something that's important to you, that's relevant to your work, and you'd like to use that maybe in a report, in a slideshow. You can make a map. I'm a GIS specialist, and I'd be remiss if I left this presentation without showing you how to make a map. So once you've decided and selected your area of interest, what variables you're interested in, you can scroll to the bottom of the tool and you'll see this first option to download the map as a PNG, as an image. So that'll give you a still image, a map that you can use. You can also download the data. If you're a more advanced GIS user, you might want the data in a raster format to use in GIS applications. And so you're able to download that data as a TIFF and do that. And this tool is already being used. I'll just run through a couple of quick examples to show you how. We've partnered with the 1854 Treaty Authority, which is outlined in the yellow portion of this map, and it includes 3 Native nations to provide climate projections for updating the 2016 Vulnerability and Adaptation Plan for the 1854 ceded territories. So this work is wrapping up now, so keep an eye out for the new publication by the end of this year. Another example of this data being used is the city of Duluth, and they used a previous generation of this data to look at storm drain and sewer models to assess the vulnerability of Duluth's stormwater system to climate change and extreme precipitation. So what can you do with this? This all sounds interesting, but you still have a lot of questions. There's a lot of ways that you can answer those. So we have tons of resources to help you use this future climate data in your work and how to remember what you've learned in this presentation. So we've got a ton of resources. One of those is the Community Climate Leaders Program. That's for people to learn how to take climate action in their lives and their community. Climate Adaptation Specialist training. Those are people who want to use climate data in their professional lives and use climate projections for long-term planning and decision-making. We have a webinar series to explore how adaptation is already happening or ways it can happen across the state and the region, and those happen quarterly. And finally, you can visit us online at climate.umn.edu. As Katie mentioned, we have a bunch of resources there. One of those is a climate modeling primer if you're interested in learning more about the climate models and refreshing yourself on what we've presented here. If you're curious about Minnesota climate news, you're welcome to sign up for our email list here. And with that, I'll wrap it up. And we'll give people time to ask some questions. Thanks everyone for your attention.
Thank you, Dina. While we wait for more questions to show up in the Q&A, or if people want to raise their hands, I'll just take a moment to address the ones that we already have in our Q&A box. So first question is, can you please talk about how wet and dry periods within a given growing season are also changing over time? That's a great question, Angie. I can't pull up specific graphs to show you, but I agree that we've already seen that within a growing season, we're seeing more extremes than we used to in terms of even, in the span of a summer from very dry to very wet. And then your question, will a changing climate lead to wind speed changes? It's a very good question, and a question that scientists are still actively trying to figure out right now. The problem is that we don't have a great historic record of wind, so that makes modeling wind rather difficult. I know that there are efforts underway to try to answer those questions, but we can't share anything officially yet. I know that from the farmers I work with, there are lots of anecdotal reports of increased wind, though.
I'll add about the first question about how wet and dry periods within a given growing season are changing over time. As I mentioned, you can use the tool to investigate how you can get outputs for specific months. So you might look at those growing seasons. I think in the tool, it defines the growing season as May through November or May through September. And so you could look at each individual month in that growing season and compare, make maps to compare how those are changing over time. Other questions? Yeah, a little more about how the climate adaptation specialist training will work. Katie, do you want to take that one? I feel like you may have been a little more involved in that.
Absolutely. So the climate adaptation specialist training program is really focused on what you do with this really great data, right? It's designed to meet people where they're at in their climate adaptation journey and include case studies from various sectors about how people have worked to incorporate this into their jobs, how they've gone about getting administrative approval or how they've gone around administrative approval for doing this work, how to get around various roadblocks when you hit questions that we don't have great answers to right now, like about future climate and wind, and also sharing resources that might help people in their climate adaptation work. A big part of what we also do is just introducing people to the concept of adaptation planning. So we have a couple of frameworks that we introduce people to that talk about how you kind of assess the most important climate risks to you or the community that you're working in, and how you might go about thinking about how to respond to those accordingly. Usually it's a group of about 15 people. We're doing those both sectorally and cross-sectorally. So that means that if people are interested in interdisciplinary approaches, they're able to do that. Or if people have very specific technical questions, they're able to connect with colleagues in their own field and share information that way. So these, we've already done one so far this summer. If you go to our website, we'll be posting when the next ones will be coming available if you're interested in attending. Dina, do you want to take that question about selecting multiple counties?
Yeah, I was just looking at that. That's a really good question, and I don't know if anyone's asked that before. I actually don't know if you can. I think if you wanted to compare against two different counties, I would go about selecting one and then downloading the map for that, or pulling the information for that, and then doing the other and sort of showing those maps side by side. I think, yeah, that's a very good question. I'm not sure that I see if you can do that. If you are a GIS person, you could also download the data as a TIFF and then bring in your own climate counties layer to compare those if you wanted to do that. Yeah, definitely. That's very helpful.
We did get a question about putting our URLs in the chat. I included the link again to MCAP's website. If you go there, it has all those resources plus the contact information for all of our staff. So if you are looking to connect with me or Dina or our climate modeler, you will be able to find our emails there. How, if any, was population changes considered in this map is another question that we received. So global climate models are, again, taking into consideration how development is happening. So if we're heading towards really intensive development in urban areas is one part of those scenarios. Another thing that global climate models take into consideration is land use. So again, if we see a shift from forest to urban development, that will have been accounted for in the global climate models, which are then downscaled for Minnesota specifically.
think let's also talk about Michelle's question. That's a really interesting question about whether we run the climate models and the projections. So to answer your question, kind of both. We run it and it's also from other sources. So these are from global climate models that MCAP did not create those climate models, but MCAP did do the downscaling to make that fine resolution that we can apply to Minnesota. So that does take that takes a lot of computing power. And so that's why you see something like, we've got these big global climate models. And so a lot of people might think, well, why don't we just make the fine resolution data that everybody probably wants available for the whole world? Well, it takes a ton of computing power. And so different labs or organizations like MCAP will do that on their own if they're really interested in it. So that's what MCAP has done. When might you have to update the data that feeds into CliMAT?
A great question. So I will say that our tool uses CMIP 6, which is the most recent version of global climate models that is publicly available, but they are already working on CMIP 7 because, again, we're based on data that they're able to collect from Arctic and past historic ice records and past observations. Our models continue to improve. One thing that I will point out, though, is that we don't, for planning purposes, there's not huge differences between the global climate models that make us think that, oh, model 6 is now not relevant or is bad now. That information is still accurate and is still entirely useful. Thanks for coming, Laura. We just got a message that someone here works for the Met Council and that it's helpful to see data for the entire 7-county region. We just have 1 more minute, so if anybody has a burning question, we'll take time to answer it. Otherwise, we will let everybody sign off. And again, we're at 1 o'clock, so thank you everybody for attending our webinar today. Again, please go to our website, climate.umn.edu. Don't hesitate to reach out to our staff if you have any follow-up questions, and continue to follow us on social media. You'll be hearing more and more from MCAP. So thank you, everybody. Have a nice afternoon.
Thanks, everyone.